Hi everyone, I'm Ausik Portal. Welcome back to my channel. Today I'm going to solve a problem from hydraulics open channel flow. In the figure you can see a hydraulic sump is assisted by a concrete block which is placed just above a horizontal apron, and the question is asking you to find out the force exerted on the concrete block due to the flow. The discharge given here is 6.64 meter cube per second per meter width, and the width is per meter. 1 meter width we have to take. That is, the width is 1 meter, and depth before and after jump are given as 0.5 meter and 3.6 meter. You can see this is equation number one, section number 1, and this is section number 2, just before and after jump. So let's say y1 is equal to 0.5 meter and y2 is equal to 3.6 meter, and the specific discharge q is given as 6.64 meter cube per second per meter. So let's apply the momentum principle between the upstream and downstream. So applying the momentum principle here to get the force exerted on the concrete block. Momentum principle between the upstream and downstream of the concrete block, that is, it states that the net force exerted on the control volume is equal to rate of change of momentum, beta 2 b2 minus beta 1 b1. Now I have taken this formula from the momentum principle from fluid mechanics. So here the beta 2 and beta 1 are the momentum correction factor, and we take beta 2 is equal to beta 1 is equal to 1. So this is the momentum correction factor. We always take the momentum correction factor 1 if it is not given. So let's say this section 1 and between this section 1 and 2 we take this as a control volume, and towards the control volume always there is a force is acting, hydrostatic force. We assume that this is the hydrostatic force E of 1, and E of 2 acts toward the control volume. It is assumed that both hydrostatic force occurs just before and after the hydraulic jump. So we can say this E of 1 and E of 2 are directing toward the control volume. So you can say like E of 1 minus E of 2, and there is a reaction on the concrete block. Okay, we can say this reaction is a R. Okay, so minus R is equal to rho Q V2 minus V1. I can say this is equation number 1, equation number I. So we calculate these 5 parameters, that E of 1, F2, Q in terms of specific discharge, B2 and B1. Okay, and substitute over here. Let's get 5 variables and substitute in this equation number 1 to get the answer. The answer is R. You are supposed to find out the force exerted. That is, we can assume this is a reaction. R is acting in the opposite direction as the Newton's third law states. So let's go to find out the E of 1, that is hydrostatic force at section number 1. E of 1 is equal to gamma A1 x1 bar. Okay, so E of 1 is equal to gamma A1 x1 bar. And how much is A1? Look at the section 1. You can say A1 is equal to B into Y1. Okay, B into Y1. You have got B is equal to 1 meter and Y1 is equal to 0.5 meter. You can say 0.5 meter square is A1. Okay, and x1 bar is how much? X1 bar is the distance from free surface to the centroid of the cross-sectional area. Okay, contact area. So you can say like Y1 by 2. If Y1 is the depth, then Y1 by 2 is the x1 bar. That is 0.5 by 2, that is going to be 0.25 meter. So you can say like E of 1, E of 1 is equal to how much? E of 1 is equal to gamma, that is 9810, and A1 is equal to 0.5, and the x1 bar is equal to 0.25. If you substitute all the value, you are going to get like how much is the E of 1? You can calculate this. F1 is 9810 into 0.5 into 0.25, that is going to be 1226.25 Newton. This is F1. Okay, I've got F1. So likewise, I'm going to calculate the F2 over here. So let's go to calculate F2. The F2 is, you can see in the section 2 that F2 can be calculated same as way you have calculated F1. So F2 is equal to gamma A2 X2 bar. And how much is A2 here? The A2 is B into Y2. How much is B? B is taken as 1 meter and Y2 is 3.6. That is going to be 3.6 meter square. So, and the X2 bar is how much? X2 bar is Y2 by 2. That is, Y2 is how much? 3.6 by 2. That is going to be 1.8 meter. Okay. So, it is going to be 1.8 meter. If you substitute these values over here, then you are going to get the F2. F2 is equal to 9810 into 3.6 into X2 bar 1.8. That is going to be how much? (9810) into 3.6 into 1.8. That is going to be 63,568.8 Newton. That is going to be this much. So you have got F2 also. So let's calculate the Q, specific discharge Q. For that, let's calculate the capital discharge, capital Q. That is discharge, that is going to be small q into B, because you know that Q is equal to capital Q by B. So we have got small q how much? 6.64, and B is how much? 1 meter. That is going to be 6.64 meter cube per second. Okay. So you have got the discharge too, and and in equation number 1, let's again look at the equation number 1. In the equation number 1, we have got how much? Many variables here. In the equation number 1, we have got so you have got F1, F2, and discharge capital Q, and let's find out the B1 and B2. Okay, and after that we can substitute the value of B1 and B2 over there in equation number 1 to get the reaction R, which is equal to the force exerted. Okay, so now let's go to find out the velocity V1. That is, V1 is equal to Q by A1, and the Q is we have got Q 6.64. Q divided by A1 means B into Y1. So Q is 6.64. You have got Q as 6.64. That is 6.64 meter cube per second. 6.64 meter cube per second by B is 1 and Y1 is 0.5. If you calculate this, you are going to get how much? 6.64 divided by 0.5, 13.28. That is going to be 13.28 meter per second. Just like that, you can calculate B2 also. B2 is equal to Q divided by A2. That is Q divided by A2 means B into Y2. Okay, and the Q is 6.64 divided by B means 1 into Y2, that is 3.6 meter. So that is going to be 6.64 divided by 3.6. 6.64 divided by 3.6, 1.844 meter per second. This is going to be B2. Now let's substitute all the values. Substitute all the values in equation 1 to get the reaction. Okay, the equation 1 is F1 minus F2 minus R is equal to rho Q B2 minus V1. Okay, so how much you have got F1? F1 is how much? Let's look at the F1. F1 is equal to 1226.25. F1 is equal to 1226.25 Newton minus F2 is 63568.8 Newton, and R, you need to calculate R. Minus R is equal to rho is 1000 and Q is 6.64 into V2 is how much? V2 is 1.844 minus V1 is how much? V1 is 13.28. V1 is 13.28. Okay, you are going to get let's calculate this. Let's put this equation in the calculator. We are going to get the value of R is, let's calculate the value of R, that is 26.25 minus 63568.8 minus 1000 into 6.64 into 1.844 minus 13.28. If you do this, you are going to get 13,000. If you solve this using calculator, we are going to get 13,592.5 Newton. That is going to be, R is equal to 13.59 kilonewton. Okay, this much force, this much reaction is developed here, and you can say that the reaction is equal to the force. You can say the reaction is equal to the force exerted by flowing water on the concrete block. You can say FD is equal to R is equal to how much? 13.59 kilonewton. Okay, this is how you can solve the problem. You can apply the momentum principle in open channel flow also, just like fluid mechanics. Okay, here you can you have to apply the energy, you also have to apply the energy principle in case of open channel flow, but in this question only the momentum principle is sufficient to get the value of force exerted by the flowing liquid, flowing water on the concrete block. So I hope you understand, guys. If you have any confusion, you can ask me in the comment section. Thank you so much for watching this video. Let's stay connected, and I will upload another videos in the YouTube. So keep in touch. Thank you.